Today, we study about the basic model of multiple linear regression. Our focus will be on the partial regression coefficient. So, the primary learning objective of this session is to understand how to interpret the partial regression coefficient. The topics of this lecture will be discussed in this order. We will first study basics of the multiple linear regression model. Then, special attention is given to issues related to control of confounding factors, and finally we will go through some examples of linear regression results. In the last session, we reviewed simple linear regression, which is linear regression with one independent variable. In this session, we start to study multiple linear regression, which is linear regression analysis with more than one independent variable. Why do we sometimes want to use more than one independent variable? There are two major reasons. First, it may raise the accuracy level of prediction. Second, it may help to control confounding in relationships among variables. Let's talk about accuracy, with an example showing how an additional independent variable helps to improve the accuracy of prediction using linear regression. In this example, we want to predict age-specific death rates for French males from age at death and year of death, using the data that we used for the software examples in the last session. In these equations, y is the logarithm of age-specific death rate, x1 is age, ranging from 60 to 90, and x2 is calendar year, ranging from 1960 to 2005, in 5-year intervals such as 1960, 1965, 1970, etc., up to 2005. Y hat is the logarithm of predicted age-specific death rate, whereas y is the logarithm of observed age-specific death rate. Epsilon is the difference between y and y hat. Alpha, beta 1, and beta 2 are parameters of the regression models. Alpha is called the constant, and beta is called the regression coefficient. Beta is called the partial regression coefficient if there are more than one independent variable, that is more than one x. So, beta 1 and beta 2 in Model 2 are partial regression coefficients. First, I set up a regression model for predicting the log death rate from age by using simple linear regression, which is Model 1. The regression analysis produced estimated values of alpha and beta. With those estimated values, now Model 1 is set up as y equals minus 9.721 plus 0.092 times x1, which is age, and plus epsilon. Then I set up a regression equation for predicting the log death rate from age and year. The equation is Model 2 here. The regression analysis estimated Model 2 as y equals 24.683 plus 0.092 times x1, which is age, plus minus 0.017 times x2, which is year, and plus epsilon. These graphs show how accurately Model 1 predicted log death rates. The left panel is a plot of log death rate by age. The right panel is a plot of y, observed log death rate, by y hat, predicted log death rate. On the red line, the value of y and the value of y hat are equal. If all points are exactly on the red line, the prediction is 100% accurate. Note the left and right panels show exactly the same pattern. Why the same? It is because in the model, y hat is a function of age x1. In the model, y hat is solely determined by x1. So the relation between x1 and y is exactly the same as the relation between y hat and y. Anyway, the graph in the right panel shows how closely the observed values and the predicted values match. In the right panel, circles scatter quite narrowly around the red line. This suggests that Model 1 predicted the log death rate from age quite accurately. In this slide, the left panel is a copy of the right panel in the previous slide. The right panel is a plot of y by y hat, predicted not just from age, but from age and year together. In the left panel, circles scatter quite narrowly around the red line, but in the right panel, all of the circles are very close to the red line, which means, for each of those points, the value of y and the value of y hat are almost the same. By comparing the results of Model 1 in the left panel, and those of Model 2 in the right panel, we notice that, by using not only information on age but also information on time, Model 2 has notably improved the accuracy of prediction, in comparison with Model 1, which used information on age only.